Welcome to all my dear students. Myself Soros Kumar Sethi, lecturer in chemistry of Nalanda Vidya Mandir, Plus 2 Science College, Berhampur. Today we are going to discuss one of the most important unit, that is electrochemistry. It is from physical chemistry. A long question, that is which carries 7 mark and 3 mark problematic questions are often asked from board exams, and for the competitive point of view it is very much important chapter. Okay, so today the unit is, that is electrochemistry. So on this lecture class we will discuss, that is introductory part, introduction. Okay, then next, that is conductor. If we talk about types of conductor, then metallic and non-metallic conductors, electrolyte and metallic conductor, that is electrolyte, electrolytic and metallic conductor. Metallic conductor, then strong and weak electrolyte, strong and weak electrolyte, strong and weak electrolyte, then electrolyte and non-electrolyte, electrolyte and non-electrolyte. Okay, then concept of redox reaction, concept of redox reaction. So come to the point, that is electrochemistry. What does it mean for the electrochemistry? Electrochemistry is nothing but it is the interconversion of electrical energy and chemical energy. In simplest way, we can mention it, that is interconversion of chemical energy and electrical energy. Electrical energy. These are the interconversion. Okay. So in complex way we can mention it, electrochemistry, it is the branch of science, it is the branch of physical chemistry which deals with study of interconversion of electrical and chemical energy. Electrical and chemical energy. This is the definition for electrochemistry, that is, it is the branch of physical chemistry which deals with the study of interconversion of electrical and chemical energy. While we are talking about that electrical energy, before going to this part, this topic, we should know first what is that how electrical conductivity it shows, through which electrical conductivity it shows, then how electrical energy convert into chemical energy. So before dealing with this topic, this word, we should know at least its basics. Basics knowledge should be required to get it understand with very beautifully. Okay, so basics are, that is conductor, conductors. What is conductor, non-conductor and semiconductor? You have already discussed. You learned from the first chapter. Okay, that is from band theory, from the solid state chapter. And while we are talking about the chemical energy, the basics from the chemical energy, that is redox reaction, because the chemical energy is generated through the form of redox reactions. In a particular cell, how the chemical energy it does. The chemical energy is does through the redox reactions, and how the redox reactions occurs, okay, and through the spontaneous redox reaction, how it changes to the electrical energy. So these two topics, before going to dealing with this, we should have at least basic knowledge upon conductor and redox reactions. Okay, so step by step we will discuss all these things. The first one, that is conductors. From the last chapter, that is solid state, we have already discussed that conductor is nothing but it is the substance through which electricity can pass. Okay, the substance through which electricity pass. Electricity can pass. Okay, this is conductor. Again, that conductor is of three types. That is non-conductor. It is of three types. Okay, non-conductor, that is insulator. Conductor, semiconductor. Okay, conductor is of two types again, that is metallic conductor and electrolytic conductor. Electrolytic conductor. From the last unit, that is solid state, we discussed that generally metals are good conductor of electricity. Why? Because in metals, due to the vibration of electron or movement of electron over it, that causes flow of electricity. Okay, so metallic conductor is due to the movement of electrons. These are responsible. The metals are conducting electricity through movement of electrons, due to movement of electrons. And electrolytic conductor, these are showing conductivity through movement of ions. Okay, so electrolytic conductor, before going to this, we should know first what do we mean by electrolyte. Electrolyte means the substance which in its fused state or in molten state or in aqueous state it conduct electricity, that is known as electrolyte. Or we can say the substance which dissociate into its ion in aqueous state, in fused state, that is electrolyte. Example, sodium chloride, NaCl. NaCl is a crystal. It is in solid form. So in solid form, sodium chloride is it cannot be said as a conductor. But in its molten state, in aqueous condition, the sodium chloride solution can be a good conductor of electricity. Why? Because in aqueous conditions, it gives Na plus Cl minus due to the provide of ions that conduct electricity very easily. So here electrolyte is sodium chloride, because electrolyte are those substances which dissociated into ions, that is cations and anions, positive ions and negative ions, in its aqueous solution. Okay, this is electrolytic conductor. So here metals conduct electricity through the movement of electrons, whereas electrolytic solutions it conduct electricity through the movement of ions. So now move on to the difference between metallic conductor and electrolytic conductors. These both are the metals and electrolytes. These both are conduct electricity. But what are those differences in between them? We are going to dealing with that. Okay. So my dear students, shall I rough it? Electrolytic conductor, metallic conductor. So metal and electrolyte both are showing conductivity, but the main difference between them is that is the conductivity is due to movement of ions. But in case of metals, the conductivity is due to movement of electrons. Okay, then it involves transfer of matter. In the form of ions. Okay, in the form of ions. It does not involve transfer of matter. It does not involve transfer of matter. Okay. Conductivity increases with increase of temperature. It decreases, conductivity decreases with increase of temperature. Okay, here conductivity is low. Here conductivity is high. So these are the basic difference in between these two. The first one, electrolytic conductor. See, here example we can take, that is NaCl, that is H2SO4, hydrochloric acid, NaOH, KCl, potassium chloride. Okay, so these are the electrolytes. Generally, strong acids, strong base and salts are showing electrolytic conductor or electrolytic conductions. And the metals, example we can take, that is copper metal, silver, aluminium. Okay, then so these are few metals which shows conductivity. So almost many metals are showing conductivity due to the free movement of electrons. Here similarly As like of metallic conductor, here also it is regulate its conductivity through the movement of ions only. So when these electrolytes in its aqueous conditions, it gives ions on aqueous conditions, aqueous solution. It provides ions. So these ions are responsible for conducting electricity. Similarly, all the metals, here all the metals, iron, okay, cobalt. So these are some metals which conduct electricity. These metals having free electron. These free electrons are responsible for increasing conductivity. Okay. The first one, that is conductivity, is due to movement of ions. In metallic conductor, the metals shows conductivity due to movement of electrons. It involves transfer of matter in the form of ions. So sometimes in case of electrolysis, due to the movement of ions, the matter exchanges, or we can say the matter transforms. Okay. So here we can write that matter can be transferred in the form of ions. But in case of metallic conductor, it does not allow. So in metallic conductors, transfer of matter is not allowed. Okay. Conductivity is increases with increase of temperature. Here, when the temperature is increases to the aqueous condition of electrolytic solution, then the dissociation will rapidly increases. Due to the dissociation increases, conductivity will be increases. But in case of metallic conductor, if we raise the temperature upon a specific metal, for example, if we take piece of iron, okay, over the iron some free electrons will be there. If we raise the temperature, then it will vibrate, it will affect to that motion of kernel that is positive, that is Fe2 plus or Fe3 plus ions, that is called as kernels. It will affect the vibratory motion of the kernel, which will oppose the conductivity, okay, which will resist the conductivity. So here we can say by increasing the temperature, conductivity decreases. But in case of electrolytic conductor, by increasing the temperature, dissociation will rapidly occur, result of which conductivity also increases. Conductivity is low, whereas conductivity is high. Here, example sodium chloride, H2SO4. So we can take all the examples from the strong acids, strong bases, and the salts came from strong acid and strong base. That is strong electrolyte. Okay, so most of all the electrolyte, it does not shows the good conductivity. Some electrolyte it will show, that is up to great extent of electricity, that is great conductivity, and some electrolyte it will shows less extent of conductivity. Examples we can take, that is acetic acid. Acetic acid is a electrolyte, but its conductivity range is not up to that mark, which is fixed by the sodium hydroxide, NaCl, H2SO4, like that. Similarly, hydrogen cyanide, HCl. Similarly, ammonium hydroxide. So these are few electrolyte which is called as a weak electrolyte, whose conductivity range is very very low. Okay. So now we will discuss, that is what is strong electrolyte and weak electrolytes. You know, what are the difference between them? So I hope all of you got this from this lecture. So weak that is electrolytic conductor and metallic conductors. This is the basic things to provide the great knowledge towards the conductivity, that is electrical energy. Okay. So now move on to, that is weak electrolyte and strong electrolyte and the difference between them. See, electrolytic solutions it shows conductivity of electricity, but all the electrolyte it does not show the same extent. Okay, few electrolytes it will show great extent of electricity, few electrolyte it will show less extent of electricity. Means it does not show conductivity properly. So what are the strong electrolytes? The electrolyte which completely dissociated. Through the difference, I am trying to make you understand with properly. Okay, so strong electrolyte means the electrolyte which dissociate, it dissociate completely into ions, completely into ions in aqueous solution, in aqueous solutions. It do not dissociate completely. Into ions. Okay, in aqueous solutions. In aqueous solution, or we can say in fused state. Okay, then next one, it is a degree of dissociation. Degree of dissociation, that is alpha, is nearly about to 1. Okay, nearly about to 1, or we can say it is equal to 1. But in case of weak electrolyte, degree of dissociation is less than 1. Means how much dissociations occurs per a particular extent of a particular measurement of solutions, that is degree of dissociations. So degree of dissociation is less than 1 here, and for the strong electrolyte degree of dissociation is somehow it is nearly about to 1 or equal to 1. Okay, next one, for the strong electrolyte, Ostwald law it is not applied. Ostwald law. Does not apply. Ostwald law does not apply, but in case of weak electrolyte, Ostwald law is applied. What is Ostwald law? I think you have already learned from this, from that is chemical equilibrium. That equilibrium chapter from the 11th class, you might have heard this term, that is Ostwald law from ionic equilibrium. How the weak acid, that is acetic acid, it dissociate, and from that, by using that laws of mass actions, we are deriving that derivations, that is Ostwald's law. Okay, so for weak electrolyte, Ostwald's law is applied, and for strong electrolyte, it does not apply. If we talk about its example, then under the strong electrolyte, all the salts which came from strong acid and strong base. Okay. Similarly, all the strong acids, that is HCl, H2SO4, HNO3, like that. All the strong bases, that is sodium hydroxide, potassium hydroxide. Okay. So, if we talk about the examples from the weak electrolyte case, that is hydrogen cyanide, CH3COOH, these are the weak acids, and weak base, that is ammonium hydroxide, NH4OH, and ammonium carbonate. Okay, the salt came from, this is salt. Salt came from weak base and weak acid. So these are few examples from strong electrolyte and weak electrolytes. Okay. Now move on to that is electrolyte and non-electrolytes. See, only electrolytic solutions which shows that is great extent of electricity. Okay, or we can say that is a conductor of electricity. But some few things are there, few substances are there which cannot be said as a electrolyte, namely commonly named as a non-electrolytes. Okay. Some non-electrolyte means we can say the substance in which it does not dissociate into ions in its aqueous conditions, result of which it does not passes electric current. Okay, once again I am telling to you, non-electrolyte means the substance which does not dissociated into its ions in aqueous conditions and does not pass electric current. That is non-electrolyte. If we talk about the difference between them, that is electrolyte and non-electrolyte, then it would be generally in non-electrolyte, the substance cannot dissociate into ions. If it does not dissociate into ions, then it will not show conductivity towards the electric current. If we talk about that is electrolyte and non-electrolyte, electrolyte and non-electrolyte, electrolyte and non-electrolyte, first thing we can say which the substance which allow electric current to dissociate into ions. Okay, the substance which dissociate into ions through the help of electricity, that is electrolyte. But here from the non-electrolyte, its definitions it would be which does not allow, which does not allow electric current to dissociate into ions in aqueous condition, in aqueous solutions. Here also we need to write it in aqueous solutions. Okay, then the next is they decomposes on passing electric current. They decomposes on passing electric current. They do not decomposes. On passing electric current. Okay, here the electrolytes it decomposes into ions in the presence of electric current. Decomposes means it in its fused state by applying electric current it totally loses its nature, totally state its properties, that is decomposes. Okay, but in case of non-electrolytic substances it does not decomposes into its ions in aqueous conditions even after by passing electric current. Similarly, the third point it would be we can write that is, they are ionic. They are ionic. Ionic compound. They are ionic in compound. And here for the non-electrolyte, they are covalent. They are covalent. Okay? Ions are formed. Ions are formed in aqueous condition. In aqueous solutions, ions do not form. Do not form in aqueous solutions. Okay? If we take its example, then under the electrolyte we can write that is HCl, HNO3, H2SO4, KCl, NaCl, okay, NaOH, sodium hydroxide, strong base, NOH, then KOH. So these are few electrolytes which comes under that is electrolytic category. And non-electrolytes means that in its aqueous conditions it does not dissociate even after by using electric current, and those are urea, okay, sugarcane, okay, these are non-electrolytes. Now come to that chemical energy part. So these are few basics which comes under that is electrical energy. Okay, because electrochemistry it says all about the interconversion. Electrochemistry it says all about interconversion of chemical energy into electrical energy. Okay. Electrical energy, before going to deal with that word that is electrical energy, we should have at least minimum idea about the conductors, electrolyte, non-electrolytes, weak electrolytes, strong electrolytes. Okay. Similarly, to deal with the word that is chemical energy, we should have minimum idea about redox reactions, because chemical energy can be sourced by that is through redox reactions, spontaneous redox reactions. We have already discussed that part from 11th class on chapter number 8, that is redox reactions. Now move on to that part. Okay, for revision purpose, I want to see how much you have knowledge about that. Okay. See, redox reaction. Redox reaction means read means that is reduction reaction, and OX that means oxidation. So those chemical reactions which shows both reduction and oxidation, that is called as redox reactions. If I take the example that is iron pin, okay, iron formula is Fe. Iron pin is placed in copper sulfate solution inside the beaker. In a beaker, it's having some copper sulfate solutions. Okay, inside that solutions, if I put iron pin and left over for the 15 to 20 days, then what you will get, that iron pin, the color that is brown, it is coated by the copper material. Okay, so iron pin is dipped inside the copper sulfate solution, then the product will be FeSO4 plus copper. So this is the reactions which is you have already learned from that class 11th and this is the reactions you have already learned from the class 10th, that is types of reactions, chemical reactions. So here oxidations, in here the iron it is present in free state, so charge will be 0, and this iron in ferrous sulfate its charge is +2, so 0 to +2, it means that is loss of electron, that is oxidation, loss of electron, that is oxidation. And here copper whose charge is +2, and here copper which exists as a free state, charge is 0, so +2 to 0, that means accepting of electron or gaining of electron. So gain of electron is reduction. So this is the chemical equations which presents both, which contain both, that is oxidation and reductions. So it is a redox reaction. It is redox reactions. Okay, it is redox reactions. Sodium chloride NaCl in crystallized form, that is solid form, on its aqueous conditions it gives Na plus Cl minus. Okay, so how this Na plus comes from the sodium metals? When one electron it loses, it becomes sodium plus, means losing of electron or loss of electron, that is oxidation. Similarly, chlorine, from the chlorine gas, when it accept electron or gain electron, it gives Cl minus, or generally chlorine it exists as a Cl2. Okay, when 2 electrons it gains, then it will be 2 Cl minus. Okay, so this is gain of electron, that is reduction. So if those reactions, for example this one, that is iron pin dipped inside the copper sulfate solution, so it gives ferrous sulfate and a copper, this reaction it can be said to be redox reaction, because here oxidation reaction and redox reaction is present simultaneously. So this is all about redox reactions, and through redox reaction, that is spontaneous redox reactions, chemical energy it is generated. Okay, so to know about that, from that spontaneous redox reactions how chemical energy it generated, we should have minimum idea about, that is electrolysis. Now we are going to discuss upon that electrolysis. I have already discussed, that is conductor, and the types of conductor, that is electrolytic and metallic conductor, strong and weak electrolyte and non-electrolyte. Then redox reaction recently I have completed, and next one, that is electrolysis. You have already learned about that electrolysis from that redox reactions last part, that is electrolysis, and you might have heard about this topic, that is electrolysis, from that standard 10th, from metals non-metal chapter. So it is not a new word for you, electrolysis, but I am again telling to you, that is electrolysis means by using electric current, when the electrolyte is split into its ion in its aqueous conditions, that is electrolysis. Through this process, few high reactive metals can be extracted from its ore, and a few medium reactive metals also. But in 10th class chapter, in 10th class from metals and non-metals unit, you have already learned that electrolysis of copper from that copper sulfate solutions. Now I am going to that topic, that part, that is electrolysis. By using minimum idea, we can go further. Okay, so electrolysis means electrolyte. Electrolysis means electrolyte dissociate into ions, dissociate into its ions on passing electric current, on passing electric current. Okay, that is electrolysis, and through this electrolysis metal can be extracted. So through this metals are extracted. Metals are extracted from its ore. Metals are extracted from its impure form. And now we are going to discuss that is electrolysis of copper sulfate solution. Okay, so here it is the vessel. Two electrode have been dipped into its salt solution, that is copper sulfate solution. So these are the copper rods, two copper rods. This is impure copper. This is pure copper electrode. Okay, and here copper solution, sulfate solutions is there. Okay, one is anode and another one is cathode. Here anode is the electrode which is attached to that positive part of battery. Okay, and the cathode is that electrode which connect to that positive part of the negative part of the battery. Okay, so what happened here, the copper sulfate solution, it is the aqueous condition of copper sulfate. This copper rod, it will loses on anode. This copper loses 2 electrons. It loses 2 electrons minus. Okay, loses 2 electron. This copper rod. Okay, this copper rod loses 2 electron to form copper 2 plus 2 electron. Here the copper charge, copper in free state, the solid form, its charge is 0, and here copper 2 plus. It means the reaction is oxidation. So try to remember this. Always oxidation reactions occur at anode electrode. Okay. Always oxidation reaction occur at anode electrode. Similarly, for cathode electrode, from that copper sulfate solutions, by passing the electric current, it will dissociate into copper 2 plus sulfate 2 minus ions. Okay, copper 2 plus and the sulfate 2 minus ions. Here the copper 2 plus ion will move upon that cathode electrode and it will deposit it over it. Okay, it will deposit over it, copper 2 plus ions here. So when this copper 2 plus ion over that cathode electrode, it receives 2 electron. Okay, then it will becomes copper solid. So copper 2 plus ion from that is aqueous conditions, where from that solution, that is copper sulfate solutions, copper sulfate solutions, copper 2 plus ion will comes to over the surface of that cathode electrode, or you can say that copper 2 plus deposited upon that cathode electrode, and there it gain 2 electrons. So gaining of electron, that means it is reduction. So try to remember, always on cathode reduction reactions occur. Okay. By combining these two, the net reaction will be, that is copper. So here the 2 electron will be cancelled out to each other. Okay. So on anode always oxidation is there, on cathode always reduction is there. Here one thing I need to make you clear, that when this copper electrode it loses 2 electron, then it becomes copper 2 plus. So here it becomes positive charge. To make it neutral, the sulfate 2 minus ion will, that is liberate to that electrode anode. Okay, that anode sulfate 2 minus ion will comes closer to that anode to make it neutral. Here the copper sulfate solution it will dissociate it into copper 2 plus and sulfate 2 minus. So sulfate 2 minus will comes to anode to make it neutral, because this electrode by losing 2 electrons it will becomes copper 2 plus ions. It means having the positive charge. So when sulfate 2 minus ion will comes closer to that is on anode electrode, it will becomes neutral. Similarly, when this copper 2 plus ions will deposited over the cathode, to make it neutral, 2 electron will adding up. Here 2 electron will adding up to make it neutral, that is copper. So likewise, that by flowing of electrons, that current will enter to that anode and leaves at cathode. Okay, current will enter at anode and leaves at cathode. So this is the electrolysis of a copper sulfate. So here try to know this thing, that is impure copper. Here the size of impure copper will go decrease, and the size of pure copper will goes and increase. It means the pure metallic copper will be extracted from that impure one, that is from anode, that is impure copper. From impure copper, a pure form of copper will be deposited over that cathode. So the pure form of copper can be found, can be extracted from that impure, and that is the applications of electrolysis. Okay. So few applications of electrolysis there, that is electrotyping, electroplating. So these are few other applications of electrolysis. But this thing you have already learned from the class 10th, that is from metals and non-metal chapter, and even you have few idea upon electrolysis from that redox reaction from 11th class. So I need to make you revise once again, that is upon electrolysis. Okay. So next class we will discuss the most important that is a topic, that is Faraday's law of electrolysis. Faraday's laws of electrolysis. There are 2 Faraday's laws. Okay. What are those 2 Faraday's laws? Along with some problems, we will discuss upon our next class. So for this lecture, this much only. Okay, students. Bye.